Hello everyone, I'm back talking once again. It's been a bit less frequent recently because I was a bit busy, but I'm trying to make it more frequent again now and gain a bit more experience again. Uh, Today I'll a theory about Kerbal space program that doesn't actually make sense, and I'll explain why it probably doesn't make that much sense, and hopefully it will be a bit interesting. So someone came up with a theory that maybe Kerbal Space Program uses different units of measurement, actually. Now, it's implied that, at least in the slightly more recent versions, I think the very first test build alpha didn't actually display any useful units of measurement, but today it's pretty much implied that it uses units of measurement like meters and seconds and meters per second and kilogram and tons and kilonewtons and things like that. But that might actually not be the case. I mean, they have the abbreviations for the Kerbals actually use different units of measurements and just give them the same names. So this was implied as a theory to astronomical unrealism of Kerbal Space Program. That is, the planets in Kerbal Space Program are a lot smaller than the ones we know, like about 1/10 the size, but their surface level gravity is about the same. And if you run the calculations, you actually come up with a density that is way too high for any normal material except for neutron stars, black holes. They have a much higher density, but any normal material that a rocky planet could be made of would be much less dense. Now, if we actually look at the equations for gravity, of course, without relativity, just Newton's gravity, we can shorten out a lot there. There's the gravitational constant, which is a constant, so if we just talk about proportional, then we can just forget that. And then there's the mass and the distance squared, which in case of the surface level gravity of a celestial body or planet is the radius squared. Then looking for mass, of course, two objects with roughly, or actually exactly, but we're only doing rough estimates here anyway, with roughly the same shape and the same density. The mass of these objects is proportional to their size or their radius cubed. So if you have a planet with the same density but twice as big, then these mostly cancel out again, and in the end, the surface level gravity ends up being proportional to the radius because mass is proportional to radius cubed, and gravity is proportional to mass divided by radius squared. So it ends up just being proportional to radius, which leaves us with a little problem for this theory. That is, if we assume that the meters in Kerbal Space Program aren't actually meters at all, then we still end up with the same problem. If we assume that 1 meter in Kerbal Space Program is actually 5 real meters because it's a different unit of measurement, just with the same name, then we would have planets 5 times as big. But we'd also end up with a surface level gravity 5 times as big, so we'd still end up with the same density, which is still way too high because it's the same. So the only real solution to this would be to assume that the seconds in Kerbal Space Program, or the units of time, are actually different. But of course, time is the only unit of measurement actually linked to the real universe because well, the game is supposed to run at real time unless you use time warp or build a really big laggy rocket. So we're supposed to know that 1 second is 1 second. Of course, we could assume that Kerbals have a somewhat different perception of time and thus have a different unit of measurement for time too. And since you basically play as Kerbals in the game, you also the game basically runs in time lapse, which is a slightly weird theory, but it could actually explain away the much too high density of the planets in Kerbal Space Program. But now, if we run the math, it turns out that for Kerbin to actually have roughly the same density as Earth, the time in Kerbal Space Program would actually have to run at about 100 times time lapse. So this could be possible, but it's rather unlikely. Though it, of course, links to another interesting thought experiment that is for any hypothetical alien species, which of course includes Kerbals, they might this might explain why they are so keen on spaceflight. Maybe they perceive time different, and thus long time journeys don't actually seem that bad for them. There's been the thought experiment before that, hypothetically speaking, there might be an alien species that perceives time differently. I mean, everyone perceives time slightly differently. Our brains aren't very precise timing devices, and a different species might live much longer and much slower and perceive time different, and then for this species, spaceflight would be much more tempting or much less unpleasant because the extremely long journey times wouldn't seem that bad. If you live for 10,000 years, then going on a 3-year journey doesn't seem that bad anymore. I might talk more about this kind of thought experiment later, but for now, the theory that the units of measurement in Kerbal Space Program are completely different from ours, it only really explains the astronomical inaccuracies if you assume that it's the units of time and that the whole game is running in time lapse. It would have to be 100 times for Kerbin's density to be that of Earth, and it would still have to be something like 10 or 20 times to make it at least potentially realistic. Now, I hope this was kind of interesting. I know the overall video quality was not really that good yet, but I'm still learning and still trying to improve. Any feedback is always welcome, and thanks for watching.